Fine. So in our previous discussion, we have discussed what are fuel cells. We have seen the definition of fuel cells, and also we have seen what are the advantages of fuel cells, differences between batteries and fuel cell, limitations of fuel cell. So today we are going to discuss the construction and the working of methanol oxygen fuel cell. So fuel cells are basically classified depending upon the electrolyte used. If acid is used as an electrolyte, it is called as acid fuel cell. If base is used as electrolyte, it is called as alkaline fuel cells. And if solid oxide is used as an electrolyte, it is called as solid oxide fuel cells. So methanol oxygen fuel cell is an example for acid fuel cells. So here in methanol oxygen fuel cell, sulfuric acid is used as an electrolyte. Therefore, this is an example for acid fuel cell. So let us see the construction and working of methanol oxygen fuel cell one by one. So this is the methanol oxygen fuel cell. So methanol oxygen fuel cell consists of anode and cathode. So this is the anode over here and this is the cathode over here. So the anode and cathode both are made up of nickel. So anode and the cathode are made up of nickel coated with platinum and palladium. So anode is coated with platinum, whereas cathode is coated with palladium. Okay, so at anode, the active species of anode is methanol, whereas active species of cathode is oxygen. So anode, your fuel cell, methanol oxygen fuel cell contains anode and cathode, both are made up of nickel electrodes. So anode is coated with platinum, whereas cathode is coated with palladium. So the active species, that is the reactants. So reactants are called as active species. The active species of anode is methanol. The active species of cathode is oxygen. So methanol and oxygen are stored separately outside. So anode and cathode are separated by a small membrane. So in between anode and cathode we have electrolyte, that is sulfuric acid. So the membrane is inserted adjacent to the cathode so that methanol will not diffuse towards the cathode. So in between, this is a cathode over here. So in between this anode and cathode, a small membrane will be inserted. So in order to prevent the diffusion of methanol towards the cathode. So when methanol is inserted towards the anode and oxygen is inserted towards this cathode, electrochemical reaction, that is redox reactions occur inside the fuel cell and the electricity will be generated. The electric current will be withdrawn here continuously and the products formed. So what are the products formed? The products formed are carbon dioxide and water. So the carbon dioxide and water will be continuously withdrawn out here. Okay. So once we stop either methanol or oxygen supply, what will happen? Electrochemical reactions will not occur inside the fuel cell. So therefore we cannot withdraw the electric current. Let us see what are the electrode reactions. As I told you, anode is nothing but it is made up of nickel sheet which is coated with platinum or ruthenium, and cathode is also made up of porous nickel sheet coated with platinum. Okay, so electrolyte used here is 5 molar sulfuric acid. The electrode reactions. So at anode, what happens at anode? We have at anode, methanol in presence of water undergoes oxidation to liberate carbon dioxide, protons and electrons. So at cathode, oxygen undergoes reduction reaction to give you 6 plus. In presence of at cathode, the oxygen will accept this 6 protons and 6 electrons and get reduced to give water. So 3 molecules of water here and 1 molecule of water here will get cancelled, and finally you will get 2 molecules of water. So the overall reaction is methanol plus oxygen. The oxygen present at cathode gives you carbon dioxide and 2 molecules of water. So how do you get 2 molecules of water? Because the 1 molecule of water present at anode and 1 molecule present at cathode will get cancelled, and finally you will get 2 molecules of water. So that is how you get 2 molecules of water. So let us see the applications, advantages and applications of this fuel cell. So advantages of methanol oxygen fuel cell. So methanol has a low carbon content. So and the hydroxyl group methanol is present is easily oxidizable, and methanol is highly soluble in water. So these are the advantages. So other major disadvantage of any fuel cell that is common, that is the raw materials are stored separately outside. So since they are stored under high pressure, so maintaining that pressure itself is difficult. That is one of the major disadvantage of any fuel cell. Okay. So what are the uses? So it is mainly used in military application. So in militaries, the major source of power is the fuel cell. So whenever you supply the raw materials, we get energy. Once you stop supplying the raw materials, energy cannot be withdrawn. So the major source, it's mainly used in military applications in hills and valleys. So used as electric power source in space vehicles and also used in large scale power production. So other applications, so methanol can be used in blend with conventional fuel cells without engine modification. And the direct methanol fuel cell, that is DMFC, is the extremely promising power source for portable applications due to its simple handling and processing fuel. So methanol oxygen fuel cell can be used, it is in portable devices. The only disadvantage is you're supposed to store the reactant separately. If it was inbuilt, then it can be used. So and it is having certain pressure. Not to maintain that pressure is difficult. Okay, so that is the major constraint with respect to fuel cells. Once, rigorous R&D is going on. So once we come out of that continuous supply, and if we can store, then fuel cells will be our future. Fuel cells will be in a future. Okay, it can be accommodated in vehicles also. So only because the pressure, if something happens in the pressure and if it explodes, the entire vehicle will explode. That is the reason they are not at all that is the main reason still the fuel cells have not used in automobiles and not come to the market. There is a small video over here. If you see this video, you will understand how the fuel cells will work, how the reactions occur in this fuel cell will come across. Just see the methanol oxygen fuel cells.
Suppose methanol is used as a fuel. We are used to methanol being used to produce heat energy. For example, when used by campers for cooking. Methanol and oxygen mix together and will not react unless a high activation energy barrier is overcome, typically by the application of a spark. A highly exothermic chemical reaction then occurs. One of the products of the reaction between methanol and oxygen is carbon dioxide. Despite this, methanol is considered to be a good fuel because it's easy to store, transfer, and transport in conventional, unpressurized fuel tanks.
This is activation. EA is activation.
The half equations which occur at the electrodes of a methanol fuel cell are shown. Remember the acronym oil rig. Oxidation is loss, reduction is gain.
Oxidation is loss of electrons, reduction is gain of electrons.
Hydrogen ions formed on oxidation move through the electrolyte. The carbon dioxide gas formed is lost to the atmosphere. The anode is plated with a catalyst. This is the most important part of a fuel cell, as it allows the oxidation reaction to occur via an alternative reaction pathway of lower activation energy. Catalysts are typically expensive transition metals, such as platinum. However, these are very sensitive to poisoning from impurities, which block active sites and reduce efficiency, lifespan, and value. The optimization of catalysts is therefore an area of worldwide chemical research.
Thank you. See, this is how your fuel cells work. Okay. In our next discussion, we'll see the construction and working of solid oxide fuel cells. Thank you.